Humanity has always looked to the stars with awe and curiosity, pondering the vastness of the universe that stretches far beyond our comprehension. For centuries, the cosmos has been a realm of mystery, its depths holding secrets that defy not only our understanding but often our imagination itself. These mysteries, while inspiring, also hinder the free flow of knowledge vital to the progress of science and the pursuit of truth. Our efforts to unravel these cosmic puzzles have led to the development of increasingly advanced tools, the most recent and powerful being the James Webb Space Telescope, JWST. This extraordinary instrument has recently uncovered a cosmic enigma that challenges the foundations of modern astrophysics, a discovery so unexpected that it calls into question some of our most deeply held scientific theories. In a revelation that has stunned the global scientific community, the James Webb Space Telescope has detected the mysterious and unexplained disappearance of approximately 900 trillion stars. This staggering number is not a marginal anomaly, it is a finding of such magnitude that it has shaken the framework of contemporary cosmology, particularly the widely accepted Big Bang theory. Joel Rogan, among other science communicators and researchers, has examined this new data in detail, offering insights into what could be one of the most profound cosmic events ever recorded. The James Webb Space Telescope, launched with a budget of around $10 billion, has been in operation for over 2 years and has already delivered results that exceed expectations. As the successor to the Hubble Space Telescope, JWST is a leap forward in technological capability. It can observe the universe in the infrared spectrum, detecting signals and celestial features previously hidden to human eyes. In July 2022, the telescope began observing distant galaxies using its ability to detect long wavelengths of light, specifically those that are redshifted, a phenomenon where light stretches into longer wavelengths as it travels across the expanding fabric of space. These long, redshifted ultraviolet wavelengths offer scientists a look into the most ancient and remote corners of the universe. What the James Webb Telescope has revealed goes far beyond what scientists anticipated. Its observations have uncovered incredibly detailed structures in space that were invisible to previous instruments. However, among these revelations is a deeply unsettling discovery: the sudden, untraceable disappearance of a massive number of stars, estimated at 900 trillion. The implications of such a finding are staggering. How could such a colossal number of stars vanish from the observable universe without leaving behind detectable remnants or radiation? Traditionally, when stars die, they leave behind some form of trace, whether it's a supernova explosion, a neutron star, or a black hole. Yet JWST data shows no signs of such phenomena associated with the vanished stars. The vacuum of space, which should have been punctuated by the aftermath of these deaths, remains eerily silent. This deepens the mystery and raises critical questions about our understanding of stellar life cycles and cosmic evolution. Two main theories have emerged to explain this unprecedented phenomenon. The first, less alarming theory suggests that the stars may not have disappeared at all, but rather may now be obscured by cosmic dust or have experienced a decline in luminosity that renders them invisible to current instruments. It's also possible that many of these stars collapsed directly into black holes without undergoing a visible supernova explosion, a hypothesis that, while extraordinary, aligns with some theoretical predictions. The second theory, however, carries more disturbing implications. It posits that the universe itself may be undergoing a fundamental transformation, one we do not yet fully understand and cannot control. This theory suggests that some regions of the universe might be fading away or entering a state of collapse or disappearance, one that defies the current cosmological models. To better understand the scope of these findings, it's essential to revisit the scientific understanding of the universe's expansion. Nearly 100 years ago, astronomers first proposed that the universe is expanding, a conclusion drawn from observations showing that distant galaxies appeared to be receding from us. This expansion, it turned out, was not due to galaxies moving through space, but rather because space itself was expanding, carrying galaxies with it. This model became central to the Big Bang theory, the dominant explanation for the origin and evolution of the universe. Then, just 2 decades ago, scientists made another groundbreaking discovery. The universe's expansion is not slowing down. As once believed, instead, it is accelerating. Galaxies are moving away from one another at increasing speeds, driven by a mysterious force now referred to as dark energy. This acceleration has profound implications for our understanding of time, space, and the fate of the cosmos. The light we observe from stars and galaxies allows us to peer into the past. When we look at a star whose light took 100 years to reach us, we are seeing it as it was 100 years ago. However, when observing galaxies whose light took hundreds of millions of years to arrive, we are seeing objects that are now much farther away than the light travel time suggests, due to the expansion of the universe over those millions of years. This expansion causes light to stretch, producing a redshift. If space were static, light would travel in a straight line and retain its original wavelength, but as space expands, the light's wavelength increases, shifting toward the red end of the spectrum. This redshift is more pronounced for more distant galaxies, meaning that the farther away a galaxy is, the more its light is redshifted by the time it reaches us. These redshifts serve as cosmic fingerprints, revealing the rate at which space has expanded over time. By studying these redshifts in galaxies at varying distances, and comparing their intrinsic brightness and size to what we observe, scientists are able to reconstruct a detailed history of the universe's expansion. Moreover, the pattern and rate of expansion reveal the contents of the universe. Current models suggest that approximately 68% of the cosmos is composed of dark energy, a mysterious force that permeates space and accelerates its expansion. Another 27% is dark matter, a form of matter that interacts gravitationally but is invisible to conventional instruments. Only about 4.9% of the universe is made up of familiar matter, protons, neutrons, and electrons. A tiny fraction, just 0.1%, consists of neutrinos and antineutrinos, and an even smaller 0.08% is made of photons. Knowing these proportions allows physicists to apply Einstein's general relativity to predict the universe's trajectory. The results are sobering. The universe is dominated by dark energy, and galaxies not gravitationally bound to one another, such as those outside our local group, will drift farther apart at ever-increasing speeds. Eventually, the space between these galaxies will expand so rapidly that even light will not be able to cross it. This means that there is a critical limit. Beyond a certain distance, any photon emitted from a galaxy will never reach us, no matter how long we wait. The accelerated expansion is pulling galaxies away faster than the speed at which their light can travel to us. At present, galaxies located 18 billion light-years away are already unreachable in practical terms, not due to technology, but because of the laws governing space itself. Our observable universe spans about 46 billion light-years in diameter, but within this immense volume, only about 6% of the galaxies remain accessible to us, even if we could travel at the speed of light. The other 94% are receding beyond the cosmic horizon due to the relentless acceleration driven by dark energy. Every second, between 20,000 and 60,000 stars transition from being within our cosmic reach to becoming forever out of range. While the light they emitted a moment ago is en route to us, any new light produced from now on will never arrive. This reality is both deeply unsettling and profoundly humbling. It underscores how fleeting our window of cosmic connectivity truly is. From a more hopeful perspective, it serves as a reminder of the urgency with which we must explore and understand the universe. If we ever hope to extend humanity's reach beyond our local galactic group, which includes the Milky Way, the Andromeda Galaxy, and roughly 60 smaller satellite galaxies, then time is of the essence. Every second that passes is a missed opportunity to venture further into the cosmos. Of the estimated 2 trillion galaxies that populate the known universe, only a tiny fraction remain within our reach. The rest are being swept away by the accelerating expansion, a consequence of dark energy's persistent influence. Unless we develop entirely new methods of intergalactic travel or discover ways to manipulate spacetime itself, humanity will remain confined to its local galactic neighborhood. Our ability to send or receive signals across the vast expanse of the universe is steadily dwindling. Ultimately, the universe is expanding at a pace that no known force, including gravity, can resist. As we watch galaxies fade into the unreachable distance, the cosmos is gradually slipping away, piece by piece, star by star, second by second. Though this realization may seem grim, it also highlights the extraordinary privilege we have to witness and study the universe during this brief moment in cosmic history when such wonders are still visible to us. If you found this exploration Of our Universe Insightful, consider supporting further content like this by liking and subscribing.